Well, let me introduce myself. I am Mr. Impedance. Basically, my job is to resist the flow of electrical current. The strength with which I oppose this current depends on my health. If my health is good, I am able to oppose current with a greater force. But when I am weak, my strength for opposition also decreases. In other words, let me lead you to a conclusion that I am just a barrier in the flow of electrical current. Greater my value, lower the value of current, and vice versa. Let me give you a little more knowledge about myself. Hey, I'm electrical impedance, and my basic job in an electrical circuit is to oppose the flow of sinusoidal alternating current. To define me, my magnitude and angles must be specified. You can also say that I am the vector sum of resistance and reactance. Let me tell you a little more about the term resistance and reactance. Reactance is the opposition to the flow of an alternating current provided by an inductor and a capacitor only. It does not apply to resistance. Whereas resistance is the opposition to the flow of an alternating or a direct current provided by a resistor only. Steady state and transient state response. Transient state. Transient state is the response of the system to a change from equilibrium. Steady state response. Steady state response is the condition at which transient or natural response of the circuit has died out. Impedance is calculated at the condition of steady state response. Now let me explain you the concept of steady state response and transient state response in a simple way. If we take analogy with bucket and water, we see that the water level rises with time. That is, the water level is in transient state. Whereas in the second case, we can see that the amount of water flowing is equal to the amount of water flowing out of the bucket. That is, the water level is in equilibrium, and thus we can say that the second case is in steady state. Well, I have three weapons, which are capacitor, resistor, and an inductor. The value of impedance for a capacitor is equal to Z is equal to 1 over j omega c. For an inductor, it is equal to j omega L, where L is the inductance of the inductor. And for a resistor, it is equal to R, where R is the resistance of the resistor. Series combination. We say components to be in series combination when the same amount of current flows through every component. This is how components are arranged in series combination, and the total impedance provided by these components in series is equal to Z equivalent is equal to R plus j omega L minus j over omega C, where R is the resistance, L is the inductance, and C is the capacitance. The value of impedance is greater in series combination. Parallel combination. We say components to be in parallel combination when the voltage across all the components is same. This is how components are arranged in a parallel combination, and the total impedance provided by these components in parallel is equal to Z equivalent is equal to 1 over R plus 1 over j omega L minus omega C over j the whole inverse. The value of impedance is less in parallel combination. Yes, you are right. It is a FM radio that you used to listen to your favorite songs and news broadcasts. But you might be wondering, what is the role of electrical impedance in a FM radio? Let me make things clearer for you. Well, the thing we hear on a FM radio is able to reach to us via radio waves. Radio waves are directed by the antennas of radio stations. These radio stations work at a particular frequency. But the problem is that there is not only one or two radio stations but many, each working at a particular frequency. Now let us see what happens upon tuning a radio device. When you adjust the tuner wheel of a FM radio, you vary the capacitance of the circuit inside a radio. By doing this, the resonant frequency of the circuit changes, such that the resonant frequency of circuit becomes nearly equal to the frequency of the radio signal received. When this happens, the amplitude of the current with the frequency of the particular radio station in the circuit is maximum and the sound of the desired radio station is maximum, and thus we simply listen to the desired station leaving out the others. And this is how a radio works. Electrical impedance tomography is a recently developed imaging technique with which images of the internal impedance of the subject can be rapidly collected with rings of external ECG type electrodes. It is fast, inexpensive, portable, and sensitive to physiological changes which affect electrical impedance properties. It consists of connecting electrodes to various parts of the body, and then a weak current is passed through the electrodes. In case of a healthy tissue, the impedance is high, and whereas in the case of an unhealthy tissue, the electrical impedance is less. This leads to the formation of different images, which helps in determining that whether the tissue is healthy or not.
And that's the end.